Hello. This section is entitled Application Lifecycle Management. Understand the primitives necessary to create a self-healing application. And this is broadly all about controllers. And the first kind of controller we're going to talk about is called a replica set. If you recall earlier, pods were ephemeral, right? So if the node goes down, the pod goes away and it doesn't get recreated, right? So to solve this, address this problem, there's a replica set, right? And it's the simplest example of a controller, so we'll start with it. Basically, the name almost means what it is. It's basically, its purpose is to create a fixed number of replicas of pods, right? And so, if pod goes down, it'll bring up a new one, basically. There are sort of three main properties of a replica set, right? One is a selector. So the selector is basically a set of labels that you can identify the pods that the replica set is managing. So it's basically how the replica set identifies which pods are the ones it's managing, right? So when it's counting, uses that selector to decide that's the number of pods there are. Next, you also need to know the number of pods that it wants to manage, right? The number of replicas, right? And then the last thing it needs is a template for a pod should it decide it needs to create a new replica, right? So those are the three things. Again, the labels or the selectors, the number of replicas it's supposed to manage, and then three, a template of a pod, how to create a pod. So there's a couple things, and we'll look at this through example, but one of the things that when a pod is being managed by a replica set, there's a thing called there's a metadata on that pod called owner references that will indicate that that pod is actually being managed by that replica set. And then another thing that's really subtle is any pod that matches the selector in the same namespace and not otherwise owned by another replica set, right, will get absorbed or get taken over or acquired by that replica set. So what that means is, let's say you have a replica set that's got a number of pods that's managing, and you independently, not through the replica set, but you actually create another pod manually, and it happens to match the same label, right? It will get picked up by that replica set as being managed, right? Even though the replica set didn't create it. And the problem then is it will delete it because there's probably already the appropriate number of pods in the replica set. So that's something that's subtle. And I think the key there is be careful about your labels. And then the last thing is when you delete a replica set, it will automatically delete all of its acquired pods. And there's an option with a cascade false where you can prevent this behavior, but the intention really is that the replica set, when you delete the replica set, you really want to delete all the pods that it presumably had created. Okay, so let's go ahead and create a replica set. Before we create it, though, we should look at it. So let's look at what they look like. Okay, so there's a folder called Replica Set, and there's a template for it. Okay, so I'm just going to skim through it, right? So API version, it's a different API group. It's under apps now, and it's V1. It's kind replica set. This is the same metadata we had earlier, nothing special there. Okay, and here's the key, right? The three main things are, one is the number of replicas it's managing, in this case 3. The selector, in this case I'm matching labels, and I just picked, you can use any labels you want, so I just happen to call the labels release and then the release name. So anything that has a label of release in this release name, which will be dev, will automatically get picked up. And the template here is the template for the pod. So it's basically, if you were to create a pod, this is basically the metadata and the spec for it, right? And the metadata here, of course, you need to set the labels. You want to have the label match this label here, right? If you didn't match these two labels, then there would be a problem. I'm not sure. I didn't test it, but it almost imagine you can just infinitely create new pods, because it'll keep on creating new pods, and those pods would not match the label, and then it would think I have to create another one. So that would be an interesting exercise to not have the same label here, and see what happens. I bet you it'd prevent you from creating it, to be honest. But either way, so you could actually have other labels here too. As a matter of fact, I just realized I'm going to pause the video for a second, because I really want, whenever I'm creating my objects, I really want my labels of my objects to have all the other labels associated with it. And I just noticed that I didn't do that here. So let me pause the video for a second, fix it, and then I'll come back. Okay, I'm back. So all I did here was I just copied down the pattern of these metadata labels we've been using pretty much on all of our objects, so that when it creates the new pods, they'll also have the same label structure. But the important one here is this one, this release right here, because it needs to, when we create these pods, for them to be acquired by these replica set, that has to match this label pattern. So that's why that's the same. The spec is just going to be Ubuntu, right? Okay, so let's do that, save that. Okay, now let's go ahead and create this replica set and troubleshoot a little bit with it. Helm install Dev Replica Set. Okay, so let's look at the replica set. Well, let's look at, first of all, let's do this. Kube control get pods. Kube control pods. Okay, you can see indeed it's created these pods. Now, I guess first observation here, there's two observations. The names, well, actually one observation, the names here. You notice the names here, I didn't specify the name of the pods in that definition here, right? Under metadata, there was no name. That's because what it'll do is it will automatically name the things for you, right? Based on, this is the name of the replica set here, and then it depends on an arbitrary hash at the end that's unique. So that's how the names get created, uniquely for your pods, right? And you see they're all running, right? Now let's look at the replica sets then. So if I say get replica sets, you can see that the example dev is the replica set. Its desired count is 3. It's currently 3, and 3 are ready, right? So it's basically, so this is how you can quickly see that things are healthy. Let's look at a little more detail. Let's describe it. I think the main thing here is, this is basically the same information we had in our spec. And I think that one thing that's interesting is you can look at the events here, and you can see, sort of a history that it created the 3 pods. Let's see if there's anything more we want to cover here. Nope. And the only thing we'll look at next is just look at the pods in more detail. And we'll look at one thing here. So let's see if I can get to that. Okay, so get pods. So we looked at the pods earlier. So let's look at describe pods or pod. And by the way, you can use plural or singular here. It seems like interchangeably. So I'm describing this pod, and in particular, let's see, what I'm looking for here is, so here it says controlled by. So you can see that this pod now knows that it's being controlled by this replica set. And then the only other thing here is, let's get the detail of it, just so that we can see that owner I'll show you what we're looking for. We're looking for, in the metadata, right, see this owner reference right here? This is essentially what I was telling you about, that this owner reference is how this pod basically is marked as being owned by that replica set, and you can see that it's referencing that replica set. Okay, I think that's really all we want to do here. Now, let's illustrate the core feature of it. If I delete one of these replica sets, delete one of these pods, let's observe the replica set will automatically recreate it. So if I do kube control delete pod, right, and then I paste this in. So the pod is gone, right? Oh, it's not gone yet, but it's being deleted. Okay, this takes a second. I'm going to pause the video for a second, and I'll let you know how long it took. Okay, I'm back. I got distracted and watched the video, but so it took only about maybe an extra 10 seconds. I just got impatient, so that's why if you look at the time, it's a little bit later. So let's first look at this. Okay, so I deleted the pod, kube control, get pods. If all is working right, there should be 3 again, right? And actually, you can already kind of hint at it here, right? So these 2 were created 7 minutes ago, and the most recent one was created 3 minutes ago. That's when I deleted the one. And then if you look at the kube control, get, describe, replica set, you will observe that you can see that an extra pod got created here, right? Okay, so the next thing we want to do is, we're going to illustrate the pattern of creating another replica set, creating another pod outside of the replica set, and watch it get acquired or by the replica set, and then end up getting deleted because it is already over the number of replicas it needed. So the way we can do this here is, if we go, there's a folder called acquiring, I think, and if you look at the template, pod, so I create a pod, and I just manually, in here I hard coded in, right? I hard coded in release dev, and that's the same label that's being used for the replica set for its matching, right? So this, and it's in the same namespace. So, oops, I had, by the way, this namespace, I'm going to delete it, but it was here earlier because I was validating that it does not pick up replicas in different namespaces. So that's how I proved that that doesn't happen. So this will now get picked up because it's in the same namespace. So if I go into here, and if I do helm install, I'll call it mistake, just my release, right? And acquiring. This will install that, basically that pod. And if I do kube control get pods, maybe there for a second and see, there's 4 of them, but you see it's already terminating. So it started up 6 seconds ago, and now it's already terminating. And that's because if I do kube control get describe replica set. By the way, if you notice, I'm not giving it a name here at the end because there's only one replica set. So you notice that this was the initial. So the history here is the first 3 were the first initial creates, right? And then I deleted one. It created another one, and now that I added one manually, it actually ended up deleting one of them, right? So it maintains the number up and down. So if there's too many, it brings it down. Okay, so that's illustrating that concept. Okay. Oh, so looking at this example here, get pods. One interesting observation is, actually I want to do one more thing. I want to show that you can actually scale replica sets. So what I'm going to do here is I'm going to go into the config. So right now this is scaled at 3, right? So if I just go into, go back into my replica set, and if I was to come in here, actually, I'm going to check the, well, here, I'll just do it real quick. I need to check these fixes in that I just did. Something like live coding here. Let's go back into the replica set, and I want to do is I want to illustrate that I can actually change this number. Okay, so I'm changing it to 4, and what I'm going to do now is I'm going to upgrade my deployment. So Helm upgrade Dev Replica Set. And what that's going to do is change the number to 4. And let's see what's going on here. So now you can see that 5 seconds ago, it spun up. So the other one stayed up, and it brought up a new one 5 seconds ago, and now my replica set maintains at 4. So that's pretty straightforward. I'm going to show you another pattern that will not work, and then we'll explain it. So you notice that here, the spec says I'm using Ubuntu 1804 and Ubuntu Docker. I think there's a newer version of Ubuntu out there. Let's say, I think it's like 2004. So what would happen if I did this? If I just came here and 2004, because I wanted to say upgrade all those pods to be Ubuntu 2004. Let's see what happens if I deploy this now. So I'm going to do the same upgrade, right? So you might be tempted to think that all of these pods will get brought down, and you'll notice that these pods will stay up indefinitely. And then you might think that you didn't do something right, so you do kube control get describe replica set, and you would indeed see that it is set to Ubuntu 2004, but nothing is really happening. Okay, and the reason why is the template is only being used whenever it needs to create a new pod, and there's nothing that happened that causes replica set to decide to create a new pod. So all my replica sets are still, all my pods are still sitting at the old version. So replica sets don't, like, all they do is, they're really kind of dumb, right? All they do is, if they need to create a new one, they use the template that it has, the latest template it has. It has no knowledge of, hey, I need to like swap things out because the template doesn't match the currently running pods. So we'll get to what we'll do that later, but replica sets do not do that. Okay, so that's it. I think now that covers the main things about replica sets. And we're going to, this is a little bit of a sidebar, although it's directly related. So one of the things we can do, so let me first of all get rid of this. There's a kube control helm ls. I think I have to remove both my mistake and my dev. So helm delete dev, and then I'll delete a mistake in a second. This takes a second, so there it goes. Helm delete mistake. Okay, I'll let that play out. Okay, so what we're going to talk about now is we're going to talk about a horizontal pod autoscaler. It's a separate feature, but it works with replica sets, and it'll work with other things like deployments, right? Essentially what they do is they scale up and down that replica number, right, based on some criteria around like metrics, right? So I think that's what I basically just said, right? And so, for example, you can use CPU utilization or memory to decide, hey, I better like bring on a new replica. So one of the things observed in the documentation is, obviously, since you're using metrics, you better have metrics, the metrics add-on added, and that we actually, I believe we did. We added that on to our environment quite a while ago. So I actually have metric servers running around. In fact, I bet you if I do kube control get pods all namespaces, I will probably see metric server floating around in here. Right there it is, right there. So I do actually have metric server running. So you can't use autoscaler without metric server. And basically, it's uses the same the controller manager that that our other controllers using, like Replica Set, right? It basically runs in a loop. It defaults to every 15 seconds, and basically it looks at the metrics that you specified and decided this based on the criteria. Decide if you need to deploy more replicas or downgrade the number of replicas. Okay, so one of the things you have to, I'm going to use a percentage-based metric, right? In order to use a percentage-based metric, you need to have like a baseline for your pod saying the pod should have at least this much of some resource, say the number of CPU, right? And then what you can do is you can say your horizontal pod scaler could say, okay, I want to make sure that if I hit 50% of that limit, I'm going to create another replica. So in order to do percentage-based sorts of, let me get it again. If you're going to use a horizontal pod scaler with percentages, you got to tell the pods themselves precisely how much memory or CPU they're supposed to have. So that's what I did in this example. We're going to come back to resource requests in a lot more detail later, but this is a light touch on it. So let's just look at the example. It's pretty straightforward. So if I go to the template, so first of all, I'm going to create a different replica set here, right? And it's pretty much, in fact, I'm going to fix this one while I'm at it too. I just realized I need to copy those labels down into my template, which is here. Okay, so just quick fix. Sorry about this. Should get for free, I guess. Okay, so this is just like the previous replica set we did, right? 3, blah, blah, blah. There's only one difference here, and it's down in here where I've added these resources. And this basically is specifying the amount of CPU that this Ubuntu will need. And this 250M is basically this right here, 250M, is essentially, I believe that's a quarter of a CPU, essentially. That's like millimeters. It's 1,000, so it's 1,000 is one CPU, so 250 Ms is a quarter of a CPU. And then this thing is not expected to exceed a half of a CPU, is the way this is written, right? Now, just we'll look afterwards to see how much our CPU is really using. But what the idea now is I'm basically telling it when the pod spins up, give it a quarter CPU, and don't, if it goes over half a CPU, do something. Right? And we'll talk about that later, what do something means. But okay, so that's one thing I need to do in order to make my horizontal pod scaler work. And then a horizontal pod scaler itself is a different API group, right? Auto scaling. Horizontal pod scaler, there's your labels that we saw earlier, right? And here I'm telling it, start with 3 replicas, go up to 5, right? And then the key here is I'm doing the scale target ref is basically pointing at the my replica set, right? So this autoscaler is looking at that replica set, right? And what it's doing here is saying the target CPU utilization is 50%. So it basically means is that if the CPU utilization averaged across all of the pods, and there's some calculations that are fairly complicated about how this all works, but generally it's, hey, if they're over 50%, bring on another pod, or scale up technically, it actually rescales the replica set to like 4 and then to 5, and the max is out at 5. Now, one thing that's a little bit tricky about this, by the way, in the docs, this line, I had to add this line in order to make this work. And the way I ended up figuring out, I mean, I did this for about an hour and not getting it to work, kept on complaining about this API version being blank. And then eventually there's a command line way of creating a horizontal pod scaler. So like there's a CLI imperative command. And I just outputted that dry run of that into the file. And I observed that command line actually added this line. So that I don't quite fully understand. I don't understand why this is named extensions v1 beta 1, but this works. So I left it as is because it was what Kubernetes generated for me essentially in that output. Okay, so let's look to see how this might work. And I think they're all gone. Helm, install dev rs hpa. So I should get a replica set, and so so look at this. If I do kube control get replica set, so yeah, I got 3 of them. They're running and they're ready. Okay, so that's all good. The next thing I want to look at is kube control get HPA. Right. And it says here, okay, it's running. Now, right now, it's got this unknown in here. That's because if I do kube control top pods, kube control top pods, it says no metrics are available. So right now, what's happening is that there are, and if I describe this. Let me describe this, and then I'll talk about what's going on. Describe HPA. So basically it says, hey, there's a problem, right? It says it's able to do it, but the scaling is not active right now because it was unable to compute basically the metrics yet. And that's because metrics server takes like maybe about 15 to 20 seconds, maybe up to a minute, before it will collect the metrics on the pods. So if I go back here, okay, now I got metrics now. So now I'm getting the pods here. So now what's happening is there's data for this HPA to look at. And right now you notice that these Ubuntu instances are basically using 1/1000th of a CPU. They're basically idle, which is expected because they're just running, they're basically doing nothing, right? And in fact, if I look at describe the HPA, it might be happy now. Yep, it's happy now. So let me clear the screen here and make it wider because it's hard to read. So now you can see up here the metrics. It's actually basically running at 1M, which is basically nothing, right? So it's basically running 0% out of essentially 50%, right? Because I was trying to get it up to 250. And I'm not even using less than 1%, right? So it's basically not going to do anything. And then the conditions here tell you a lot about the status of things. So I'm able to scale, right? And then its scaling is active, right? And then it basically says the desired count is within the acceptable range. So it's not actually doing any sort of, not really doing anything right now. So this is basically a horizontal pod scaler in action. Just there's not a lot of activity, so it's not doing a whole bunch. But enough to give you a flavor of it. Okay, I think that's all for this video, and we'll get into the next topic shortly.